All right, so 8.2, integration by parts. All right, so it's called theorem in your book. I think it's 8.1. So if u and v are functions of x and have continuous derivatives, then this formula is true. So this is the formula we're going to be using. The integral of u times dv is equal to u times v minus the integral of v du. Okay, so let's do an example. So these are the type of questions we want to use this formula. X times e to the 23x dx. So you want to choose a u that is easy to integrate and a dv, sorry, so a u that's a good derivative and a dv that's easy to integrate. And let me show you what I mean. So right here is my u and v, right? Let me lower the slide a little bit. So I'm going to choose a u of x, and I'm going to choose a dv to be e to the 23x. The derivative of u will be dx, right? The integral of e to the 23x will be 1 over 23 e to the 23x. But so notice how this derivative kind of makes it go away. That's why I chose this to be u, meaning the other one has to be dv. But you need to make sure that the dv is easy to integrate, meaning you don't need something like difficult, if you choose a dv that creates another by parts, then clearly that's a wrong choice because we're already using by parts. So this is u, this is dv in this case, and that's what we chose. So x e to the 23x dx will equal to u times v, so x times v times e to the 23x minus the integral of v du, which is just dx in this case. So then this will simply just be 1 over 23x e23x minus this integral will be 1 over 23 squared, or whatever the hell that is, 23x plus my c. So that's the idea between by parts. You see two functions being multiplied, so you have to do by parts. You choose the u and the dv yourself. Is there any questions on what we just did? Well, let's do another one. Okay, so it makes more sense to do a bunch of them. Integral of x cubed ln x dx. So what do you guys think should be u, and what should be dv? Usually that's the right choice because you want x cubed to disappear with derivatives. But if I let this be u, this becomes dv, and I need to integrate it. Can you integrate ln x easily? Right? Integral of ln x would technically be a by parts. So we're going to choose u to be ln x for that reason. Because the derivative is easy, right? Just 1 over x dx. dv is x cubed, so the integral, oh, I'm sorry. Yeah, dv. Integral would be, what, 1/4 x to the 4th, right? So this is easier to find, so now let's try the formula. So that will be, well, let's show the formula. So u and dv is equal to u times v minus the integral of v du. So this will cancel one of them, right? So ln is supposed to be, here, write this better. So this would be x cubed ln x minus 1/4 x cubed. So this integral here, dx. That'll be x cubed ln x minus 1 over 16 x to the 4th plus c. Is this making sense? Not too bad, right? By parts. Okay. All right. So what I want to show you next is the tabular method. So basically, it's like a formulaic shortcut that'll allow you to skip this formula and make it faster. Because sometimes you have to do by parts like 2 or 3 or 4 times, and that's not fun if you have to use this formula a ton of times, right? So let me show you the tabular method. Sorry, don't spam me. X to the 5th, e to the 2x. So in this case, we want to pick u to be the x to the 5th. But how many derivatives do you need to take of the x to the 5th until x to the 5th turns into a 0? It'd be at least, what, maybe 6, 5? Because you start to take it down to power, eventually it becomes a constant, and then it becomes a 0. So that's at least 6 or 7 derivatives. So that means we'd have to do by parts, like 3 or 4 times, which is not fun. So this is the tabular method. So we can avoid that nonsense. So make a little column for u and a little column for dv. So x to the fifth, one derivative is 5x4, another derivative is 20x cubed, another derivative is 60x squared, 120x, 120, and 0. So it'd be 1, 2, 3, 4, 5, 6 derivatives. Okay, so now you do the other one. The dv, this would be nothing but integrals. So one integral of e to the 2x is 1/2 e2x. Another integral would be 1/4 e2x. Another one is 1/8 e2x. 1/16 e2x. So you do it all the way down until you get to the 0. 1/32 e2x. So integrate all the way down. So this is really integrals all the way down. This is derivatives, right? And then the last one is 1/64. I should use line paper for this. Okay, so you start from the top. So the first term is plus and minus. It always starts this way. Plus, minus, plus, minus, plus, minus. 0 doesn't matter because it's 0. So then you go like this, diagonal. You pair these up, pair these up, pair these up, all the way down. So the answer to this integral here, sorry, I'm off the screen there. The answer to the integral will be the first term times the 1/2 minus the second row there times its pair plus 20x cubed times its pair minus 60x squared times its pair plus 120x times 132 minus 120 times 164. And then the 0, who cares? So once you do all the algebra and fractions, you'll end up with x to the fifth e2x over 2 minus 5x to the fourth e2x over 4 plus 20, reduce to 5x cubed e2x over 2 minus 15x squared e2x over 4 plus 15x e2x over 4 minus plus minus plus minus the last, actually that's going to be plus. Yeah. 15. Yeah, it should be minus actually. Well, if you add them together, yeah, that's fine. 15 e2x over 8. So you see how the tabular method will save you from doing this many times. So all you got to do is just pair these together by multiplication, and that's it. Is there any questions on this? that make sense or no?
Does this always work no matter what you're using this method on?
It will always work, but there's a couple of questions where it'll repeat itself, and you have to kind of like subtract it over to. So technically, remember, this is an equation, right? You have a left-hand side over here, so this is equal to all this crap, right? So sometimes you'll have this term appear again. You have to subtract it or add it over to this side and divide it out. So about 80% of the time or 90% of the time, I'd say this will always work. It'll even work for those weird examples, but those will be a little harder when they repeat. And you'll see a couple in the homework. But yeah, most of the time, if you see a term that will disappear, see how eventually there'll be no x, right? And like the last one we had, well, actually, no, not that one. Something like this, it would work. Right. You see how there's an x on it? So I'd do it a couple of times until the x would be gone, right? You'd have x squared, 2x, 2, 0. So this one would work because this will be gone. If it doesn't go away, then you have to be very careful because it will still work, but you have to be a little careful because it could get a little strange or complicated. Okay. But I want to answer your question. Yes, it will always work, but there's a case where it's harder to use. Okay.
Is it with the trig functions?
Yeah, like if you have something like this, like ex cosine, you see how it's never going to go away because they both will always be there.
Uh-huh.
So something like that, you'll notice that this method will be a little weird to apply here. You still can. It's just strange. Does that make sense? But this one, of course, would work. So you pair this one here, this one, plus, minus, plus. So the answer would be x squared sine 4x over 4 minus minus, right? You multiply that, so plus 2 cosine 4x over 16 minus 2 sine 4x over 64. And of course, those fractions will reduce, right? But you see how this is a little easier. Because without this method, you'd have to do by parts twice here.
Okay.
All right, guys, that's all I'm going to do for today. Do you have any questions on 8.2? Does that make sense? By part seems okay or no? That's good. You guys get chapter 7 done? No, I'll reopen some of it, some of the chapter 7, and I'm gonna reschedule chapter 8 because I think the dates are all messed up. So don't worry about the dates. Okay. So next time I see you, we'll do 8.3 and probably 8.4.
I have one quick question. The last test we took, um, when are you gonna apply
Oh,
the
oh,
partial credit?
yeah. I don't know if have I uploaded the grades. I can't remember. Can you see
No,
them?
it's still, at least for me, the grade that I see was the one that it gave me directly after the multiple choice.
Gotcha. Yeah, I mean they're done. I just need to upload it. I'll have it. I'll do it. I'll do it tonight. And you should see them in the morning.
Okay, thank you.
Yeah, I guess I didn't update it on my end. Yeah, just give me an hour or so. You'll see it in the morning for sure.
Okay, sounds good.
Right. Sorry about that. Chapter 7, yes. That Chapter 7 test will be published soon. Right. So, I can't remember if have we reviewed Chapter 7?
No,
Okay, so we'll review, I guess that was what I was supposed to do. I forgot. So we'll review Chapter 7 on Thursday, and I'll publish it tonight. You can take it any time between now and next Tuesday. Okay? Yeah, I think I remember I said we would review when we got back. I forgot. I started Chapter 8 instead. But yeah, we're